Welcome to our mathematics class. In this case, we will look at introduction to trigonometric functions. We will take off from where we left off. We learned that trigonometry comes in very handy by bringing with him more tools and techniques to the solutioning of all types of triangles. We also learned that there is a mathematical relationship between the angles and sides of a triangle, and that relationship is based on what is called trigonometric functions. There are 6 trigonometric functions. The first one is sine, abbreviated sin, which is also pronounced sine. Cosine, abbreviated cos. Then we have tangent. Then we have cotangent. Then secant. And lastly, the cosecant. Now let us look at the vocabulary that is used quite a lot in triangles, and especially in trigonometry, the opposite sides and the adjacent sides. Now let us consider angle alpha. The side that is said to be opposite to angle alpha, it's the side AB, which is shown in red. And the side that is said to be adjacent to angle alpha is the side that is shown in green, which is line OB. And the side that is always called the hypotenuse, it's the one that is in black and is always opposite to the right angle. Let us now focus on angle beta. Now, if you look at angle beta, you will realize that the opposite side of angle beta, it's the red one, as we have shown in the previous one, and the adjacent side of angle beta, it's the side AB, which is in green. And like I've said, the opposite side is the side that is in red, which is OB, and the hypotenuse is always the side that is opposite the right angle, as shown in black. Now let us consider the sine and see the relationship that exists between the angles and the sides of a triangle. Consider angle alpha again. Sine alpha is defined as the length of the opposite side to angle alpha divided by the length of the hypotenuse side. In short, sine alpha is equals to AB divided by OA, and then AB can be made the subject of the formula and is equals to OA times sine alpha. Let us consider or put our focus on angle beta. So in this case, sine beta would be defined as the length of the opposite side to angle beta divided by the length of the hypotenuse side. In short, sine beta is equals to OB divided by OA, and OB can be made the subject of the formula to equal OA times sine beta. So in short, we can say the sine of any angle is equals to the opposite sides divided by the length of the hypotenuse of a triangle. Let's look at now at the cosine. We consider angle alpha, and we can say cos alpha is defined as the length of the adjacent side to angle alpha divided by the length of the hypotenuse side. And in short, cos alpha is equals to OB divided by OA, which is the hypotenuse, and OB can be made the subject of the formula, which is equals to OA times cos alpha. And we can again, in this case, shift our focus to angle beta. And in this case, cos beta is defined as the length of the adjacent side to angle beta divided by the length of the hypotenuse side. Cos beta in short is equals to AB divided by OA, and AB can be made the subject of the formula, which is equals to OA times cos beta. Then let's move to the tangent, and still in this case considering angle alpha. Tan alpha is defined as the length of the opposite side to angle alpha divided by the length of the adjacent side to angle alpha, and that gives us tan alpha is equals to AB divided by OB, and AB can be made the subject of the formula, which is equals to OB times tan alpha shifting the focus to angle beta. Tan beta is defined as the length of the opposite side to angle beta divided by the length of the adjacent side to angle beta, and that gives us tan beta equals to OB divided by AB, and OB can be made the subject of the formula to give us AB times tan beta. Now let's consider the cotangent function. Considering angle alpha, cot alpha is equals to the length of the adjacent side to angle alpha divided by the length of the opposite side to angle alpha, and that gives us cot alpha is equals to OB divided by AB, and OB can be made the subject of the formula to equal AB times cot alpha. Shifting the focus to angle beta, cot beta is defined as the length of the adjacent side to angle beta divided by the length of the opposite side to angle beta, and in short that gives us cot beta is equals to AB divided by OB, and AB can be made the subject of the formula to equal OB times cot beta. The secant, in this case our focus is on angle alpha, so secant alpha is defined as the length of the hypotenuse divided by the length of the adjacent side to angle alpha. Therefore secant alpha is equals to OA divided by OB. Then OA can be made the subject of the formula to equal OB times sec alpha. Shifting the focus to angle beta, sec beta is defined as the length of the hypotenuse side divided by the length of the adjacent side to angle beta, and sec beta equals to OA divided by AB, and OA can be made the subject of the formula to equal AB times sec beta. Now let us look at the function called cosecant, and with the focus on angle alpha. Cosecant alpha is defined as the length of the hypotenuse side divided by the length of the opposite side to angle alpha. Therefore, cosec alpha is equals to OA divided by AB. Therefore, OA equals to AB times cosec alpha. Shifting the focus to angle beta, cosec beta is defined as the length of the hypotenuse side divided by the length of the opposite side to angle beta. Therefore, cosec beta is equals to OA divided by OB, and OA can be made the subject of the formula, which equals OB times cosec beta. In summary, Sine alpha is defined as the opposite side of alpha divided by the hypotenuse side, which is equals to AB divided by OA. Cos alpha is equals to the adjacent side to angle alpha divided by the hypotenuse side, which is equals to OB divided by OA. Tan alpha is the opposite side to angle alpha divided by the adjacent side to angle alpha, which equates to AB divided by OB. Cot alpha, which is the reciprocal of tan alpha, is the adjacent side divided by the opposite side to angle alpha, which gives us OB divided by AB. Sec alpha is the reciprocal of cos alpha, which is equals to the hypotenuse side divided by the adjacent, which equates to OA over OB. And finally, cosec alpha, which is the reciprocal of sine alpha, is equals to the hypotenuse side divided by the opposite side, which equates to OA over AB. And now, when we shift the focus to angle beta, we'll say in summary sine beta is equals to the opposite side of angle beta, which is OB, divided by the hypotenuse side, which is OA, which now equates to OB over OA. Cos beta is equals to the adjacent side of angle beta divided by the hypotenuse side, which equates to AB over OA. And then tan beta, it's the opposite side to angle beta divided by the adjacent side to angle beta, which equates to OB over AB. Cot beta is equals to the adjacent side to angle beta divided by the opposite side to angle beta, and that equates to AB divided by OB. The secant of beta is equals to the hypotenuse side divided by the adjacent side to angle beta, and that equates to OA over OB. And finally, cosec beta equals to the hypotenuse side divided by the opposite side to angle beta, which equals to OA over OB. And this can be remembered in a short way to say, if it confuses you, you can memorize this and say it's SOHCAHTOA, which means the sine is equals to the opposite of angle beta or angle alpha divided by the hypotenuse side. Then cos alpha is equals to the adjacent side divided by the hypotenuse. And lastly, tan alpha is equals to the opposite side divided by the adjacent side to angle alpha. And the rest that are remaining, which is your cotangent, is a reciprocal to tangent, meaning that it will be adjacent over opposite. The secant is the reciprocal of the cosine, which means secant alpha would be the hypotenuse over the adjacent. And finally, the cosecant can be remembered to be the reciprocal of the sine, which is hypotenuse over the opposite side of angle alpha. And this is how shortly it can be remembered if it gives you trouble in your early days of learning trigonometry. Now we can make an example to see how this works to use a basic application. Given a triangle with angle alpha and the hypotenuse OA equals to 10 units, and the opposite side to angle alpha AB equals to 8 units, and the adjacent side to angle alpha, which is side OB, equals to 6 units. So in this case, sine alpha is equals to opposite over hypotenuse, and that gives us 8 over 10, which is equivalent to 4 over 5. Cos alpha is equals to adjacent over hypotenuse, which is 6 over 10 equals to 3 over 5. Tan alpha is equals to the opposite over adjacent, which is equals to 8 over 6, equivalent to 4 over 3. Cot alpha is equals to the adjacent side, which is 6 units, divided by the opposite side to angle alpha, which is 8 units, which is now equivalent to 3 over 4. Sec alpha is equals to the hypotenuse over adjacent, which is 10 over 6, which is equivalent to 5 over 3. And cosec alpha equals to the hypotenuse side over the opposite, where the hypotenuse side is 10 and the opposite side is 8, and this is equivalent to 4 over 5. And this is the basic applications. We'll get into more advanced applications to use this so that you may get more familiar and more exercise will be given to you. And I would like to thank you for joining us for these lessons. Let's look forward to the next lessons where we'll be looking more detail as to what is reciprocals.